4:7, chapter 4. Somebody wants to be on the video. Chapter 4:7, transforming formulas. This moves completely away from everything else that we've been doing in chapter 4. But there is value in the sense of solving for the variable. This really reverts back to earlier chapters where we are going to isolate for a variable. In this case, we're going to isolate D. We're going to solve for D. So we have to ask the question, what's happening to D? Well, if we look at this, D is being multiplied by pi. What's the inverse of multiplying by pi? Would be dividing by pi. So we're going to divide both sides by pi, and we're left with D equals the circumference divided by pi. That is as easy and as simple as these can be. It says state the restrictions. There are no restrictions because pi is a symbol for a numeric value, and that numeric value 3.1415926535897932338. I memorized those. No, I didn't. I'm reading it off of a chart. Is not going to be 0. The only restrictions are that a variable in the denominator cannot be 0. Pi is not a variable. It's a symbol for a numeric value. It's just a placeholder for a number. We're going to solve for A. We have force equals mass times acceleration. So if we solve for A is being multiplied by m. The inverse of multiplying by m is dividing by m. So force divided by mass will create acceleration. Somebody was asking me if I wanted to teach science class earlier today, and I said no, even though I know these formulas. But that does have to do with physics, and that would be the one science class I would teach, or like to teach, or learn more about. So we're going to isolate for T. There are two things being, let's go back. We got to talk about restrictions. M cannot equal 0. You can't have a mass of 0. So I forgot about the restriction part. Let's go back to interest equals principal times rate times time. I equals PRT, a very important financial formula. So T is being multiplied by P and R. So the inverse would be divided by P and R. So we get interest equals interest divided by principal times the rate would equal the time. There are students who would do it one at a time. So some students would divide by P first. You get I over P equals RT. Now we can't divide by R because we get that ugliness. And so we would have to multiply by the reciprocal, which is 1 over R. And we still get interest over rate times P. Actually, we would do PR, alphabetical order, equals T. So same answer. This is left side's more efficient because you can do it in one fell swoop. Volume equals big B times H. Big B is the base area of the object. This is a 2 base object, and it is volume equals the base area times the height. If we're isolating for a height, we're going to divide by the base area. So V equals big B over H. And we have to keep it as a capital B, because the lowercase b is base, meaning the base of a triangle or a base of a figure, where big B is base area. We're going to solve for T. Distance equals rate times time. We're going to divide by, again, I forgot my restrictions. Sorry about that. P and R cannot equal 0. The base area cannot equal 0. Distance divided by rate equals time. R cannot equal 0. I don't know what this formula is. S equals G times T squared. Gravity times time squared equals, I don't know. I don't know that one. It might not be even anything. we're going to divide both sides by t squared because we want to get g by itself. S divided by t squared equals g, where t cannot equal 0. The formula, area equals 1/2 times the height times the quantity a plus b, gives you the area of a trapezoid with bases a. Okay, to get the clear, oh yeah, okay. So we're going to solve for h. Now here is a little bit of a tricky one. I'll do the longer form of this. Let's get rid of the 1/2. We're going to multiply by 2. So we get 2a equals base times height. And then we're going to divide by b. And you get twice the area divided by the base equals the height, where b cannot equal 0. That's one way of doing that. We could have done it in one fell swoop. You would have a equals 1/2 b times h. If you multiply by 2 over b, 2 in the numerator, 2 in the denominator, b in the numerator, b in the denominator, is the most efficient way. 2 and a are in the numerator, b is in the denominator, and that's how you can isolate. That's sort of the high school way. We're going to isolate for y. What's happening to y? 2b is being added to it, so we're going to subtract 2b. Those are like terms, so we get negative b equals y. Oh, I forgot about restrictions. And b cannot equal 0. I love how I get to the next problem and continue to remind myself. There are no restrictions here. You get the opposite of b equals y. You can combine like terms. We're going to isolate h. Area equals 1/2 h times the quantity b plus c. This is a fun one. We can multiply by 2 to get rid of the 1/2. That gives you twice the area equals h times the quantity b plus c. So I'm trying to get h, and it's being multiplied, so the inverse of multiplying b plus c, is dividing by b plus c. So 2a over b plus c equals h. You don't need parentheses in there, and that's probably the easiest way. You could have done it a little bit faster, but b and c cannot be opposite of each other. So I don't know how we say can't be opposites. Can't be opposites. And they can't be opposites because if they are opposite, they would make 0 in the denominator. But I don't know how you word that. I would word it that they can't be opposites. We're going to isolate r. So there's a number of things happening to r here. We have p plus p times rt. I'm going to get rid of things being added and subtracted first. So we get a minus p equals p times rt. We're still isolating for r, so we're going to divide by pt. Divide by pt, and we get a minus, whoa, that's not a minus, over pt equals r. That's acceptable. Even though you have a p in the numerator and a p in the denominator, we cannot cancel that. We could, so we could do this. We could write a over pt minus p over pt equals r, and we could simplify that to a over pt minus 1 over t equals r. That's the only other answer. These p's will cancel only when they are in their own fraction. When here, this pt is, as we saw, it's over both of those, so we can't cancel them when they're in a vinculum like that. We would have to separate them into their own fractions. We're going to isolate for L. We can't get in there because good old, that's not my strongest. There you go. So a lot of students would distribute in, thinking that's how you get rid of Chewbacca. which it could, but that just makes your L even bigger. So I'm going to get rid of the 2, and that's going to get rid of Chewbacca. So A divided by 2 equals L plus W. Chewbacca went home, and now we can isolate for L by subtracting W. So we get A over 2 minus W equals L. That's your best way. I wouldn't do this, because now you're doing this. You have A minus 2W equals 2L divided by 2. You have to divide everything by 2. You get A over 2 minus W equals L. Same answer. 6 of one, half dozen the other. Left side is more high school and smarter. F again, we have Chewbacca. We got to get rid of that 5/9. We're going to multiply by the reciprocal. So we'll multiply both sides by 9/5. Multiply by 9/5. We get 9c over 5. I like that answer. F minus 32. And now we just add 32 to both sides. 9c, oh, that's a capital C. 9c over 5 plus 32 equals Fahrenheit. And that's the way that you convert Celsius to Fahrenheit. The original is converting Fahrenheit to Celsius. So that's a nice way of doing it. This again, solve for V. Okay, S equals V over R. R is in the denominator. So if I multiply by R, I can get rid of it. So that's going to be my, oh, I forgot. The whole entire time I forgot. No restrictions here. No restrictions here. Our restrictions here are P and T cannot equal 0. Going back, sorry. Oh yeah, we did that one. Okay, so I only skipped 1 or 2. Sorry about that. No restrictions here. Yeah, R can't be 0. I know R is not in the denominator at the end, but it is in the beginning, so we can't start with R being 0. So anywhere upon that, throughout that, D equals M over V. Solve for M, we're going to multiply both sides by V. dV equals M, and V cannot equal 0. Hey, I remembered the restriction. C equals mv squared over r. We're solving for m, so we can multiply. We can do this in one step. That's where it's more efficient. That's a v. Looked like an r. That looks like an r. Okay, because v's in the numerator, so the inverse would be in the denominator. R is in the denominator. The inverse would be if it was in the numerator. That's all we're doing. Since everything is multiplying and dividing, we can do it in one step. We get C times R over V squared equals M. And we're going to say R can't equal 0 and V can't equal 0. We're going to solve for X. Okay, this is a big, oh, I like this. So this is an interesting problem in chapter 4. So I'm going to move my AX's over to the same side. And I'm going to move my constants over to the other side. So we get AX equals 6. No, equals 4. Because 2AX minus AX, we are like terms. We're going to combine their coefficients. 2 minus 1 is 1. We would never write 1AX. And then we're solving for x, so we're going to divide by a. And we get x equals 4 over a. And a cannot equal 0. Solve for u. Ooh, this is a good one. I like this. V minus u over t. We have to get u. We can't get rid of that v yet. And we can't multiply by the reciprocal. That is not being multiplied and divided everything. We have an addition and subtraction in that numerator. So we first have to get rid of that t. So we have AT equals V minus U. And now we can move the V. So we'll subtract, that's a bad V. Subtract V. Here's a little trick. Did you remember to keep the negative with the U? Hopefully you did. And then we will multiply everything by -1. When we multiply, we have to multiply all the things on the left side. So that's going to be opposite of AT plus V equals U. That's a little tricky one. We have A here, so V squared equals U squared plus 2AS. We're solving for A. We're going to get rid of that U squared first. Okay, I'm going to write it in standard form, even though it pains me to write the negative first. 2AS. We're isolating for A, so we'll divide by 2S. Opposite of U squared plus V squared all over 2S equals A. And that's a suitable. Did I forget? I forgot this. T cannot equal 0. I went one problem without forgetting again. But I remembered because I looked at this. So S cannot equal 0. Solve for A. N over 2A plus 1. We can't get into the A. We got to get rid of that N over S. The inverse is 2 over N. 2 over N. You get 2S over N equals A plus 1. Parentheses are gone. Subtract 1 from both sides. 2S over N minus 1 equals A. And N is the only value that can equal 0. It's the only variable that is in the denominator throughout the problem. Another good one. M equals X plus Y plus Z over 3. Let's get rid of that 3 in the denominator by multiplying by 3. 3M equals X plus Y plus Z. Now it's super easy. We can subtract Y and subtract Z. We can do it at the same time. That is viable. We get 3M minus Y minus Z equals X, and there are no restrictions. Solve for D. L, that doesn't look like an L. L equals A plus the quantity N minus 1 times D. Let's get rid of that A first. Always get rid of things being added and subtracted. Then we have N minus 1 times D. N minus 1 is parentheses, Chewbacca, so we're going to hold it together. It's being multiplied by D, so we will divide by D. Now, if you want to write negative A plus L over N minus 1, I'm okay with that. I like the standard form there. And then what can't we have in the denominator? N can't equal 0. N cannot equal 1. Because when N is 1, 1 minus 1 gives it 0. So this is a little bit different. We now aren't worried about the variable equaling 0. We're worried more about the denominator equaling 0. So we can't have N equaling 1. Oh, look at that thing. Okay, A equals A plus B plus C plus D divided by 4. We again are going to get rid of that 4 in the denominator. We get 4A equals A plus B plus C plus D. They feel that more variables makes it harder? No. Minus A minus C minus D. We can do it all in one fell swoop because we are efficient. 4A minus C minus D equals B. That's kind of silly. That's a silly problem and no restrictions. No variables in the denominator. Let's solve for B. This is again, we see that we have B on both sides. We have two B's. So let's move the BY's to the same side. And I kind of wanted it to be a positive. And now I'm going to move the 2 back over. I get by equals 2, and I'm solving for b. I'll divide both sides by y. b equals 2 over y. We definitely know y can't equal 0. Any other variable in the denominator? Nope. That's it. Solve for a. 3aw plus 1 equals aw minus 7. Let's get the aw's. On one side, let's get the constants on the other. That's 2aw equals negative 8. We're solving for a, so we'll divide by 2w. And that gives us w. Nope, that gives us a equals negative 8 over 2w, which can be simplified. Negative 4 over w. And w cannot equal 0. And that's it. So you do have to, those are constants, you need to reduce that fraction. ax plus b equals c. Solve for b, we're going to get rid of ax because it's being added and subtracted to b. b equals negative ax plus c. No restrictions. Okay, d equals a over 2 times the quantity 2t minus 1. We're not going to distribute. We're going to isolate for a, so we're going to get rid of that 2 in the denominator by multiplying by 2 in the numerator. That's 2d equals a times the quantity 2t minus 1. Now we're trying to get a, and it's being multiplied by this quantity, Chewbacca, holding it all together. So we'll divide by 2t over 1. 2t minus 1, excuse me. 2d over 2t minus 1 equals a. We cannot cancel the 2's because that's a binomial. So we can't cancel those 2's. That's under very different. My denominators, t cannot, okay. It's not t cannot, well, yeah, because if t is 0, that denominator becomes negative 1. So t cannot equal 1/2. So 2 times 1/2 would make 1. 1 minus 1 would be 0. So that's another tricky restriction. Oh, yes. There's some fun stuff that you can do here, but we'll leave it at this. I'll do it both ways. We can do this easy. Add bm, am equals bm plus c, divide by m. And we get a equals bm plus c over m. Some math teachers would want you to simplify this and put bm over m and c over m. So this is okay sometimes. And then this equals b plus c over m. And this is another acceptable answer. Here's a cool way to do this one. Let's duplicate this, clone it, and clear it. I'm going to factor out an m, and that gives me a minus b equals c. Now we can divide by m. We get a minus b equals c over m, and then we're going to add b. So that's a nice, really efficient way getting that same secondary answer. So we still get that bottom one. We get it right there. So it's just flipped a little bit in standard form. But that's a very cool way, seeing that you can factor a common factor. M is being multiplied by both of those terms. Not necessary, but let's talk about restrictions. M cannot equal 0. So I think this is the last one. Last problem, solve for p. This is pretty easy. It's so funny how they do this. They give you a hard one, and then they give you quite the layup for the last problem. I guess this is somewhat, you have to multiply by 100, and what you have to remember is to distribute to everything on the left side. So you get 100q minus 100 equals p. So don't forget to distribute that to both. No restrictions. All right. That is, variables aren't harder. Variables are actually easier because most of the times you can't combine those variables like you can combine constants, like a two-step or a multi-step isolating. Have a good one.